Okay, so I'm not gonna be here tomorrow. That's like close up. So I'm going to record a video for you today. To finish the notes that we started on Tuesday. Okay. All three of my classes on Tuesday left off on different points. What all of you did was, I know you at least wrote this down and started to understand like how the fence method works. Some of you got to this time example where all of you did it. All of you discussed how you would do this, but I did not actually do this example for everybody, okay? And then some of you actually got to like the next question over here. So here's the thing that I'm gonna say, because depending on if you're in second period, fourth period, eighth period, you might need to fast forward to later in the video. I'm going to actually start it up here because I know my eighth period didn't get to this. Okay, and I'm going to do this time example for them. If you have the time example in your notes and you understood it, fast forward to the next example you need. You don't have to watch the whole video. And if you were maybe in class but were a little bit confused or you want a refresher, this is a good place for you to get it, okay? So that's how we're gonna do it. Let me grab my stylus real quick. Okay. All right. So the purpose of the fence method is to give you an efficient way to solve conversion problems. Okay. And we're going to use this next week in a more complicated example. So I want you to practice using the fence this week on some easier examples. Okay. The overall setup for the fence is like typically in a problem, you're given a measurement, which is like a number in a unit. Okay. And using a conversion factor, you need to change that unit to a different unit. Okay. If the problem's really simple, you only need one conversion factor. But like in that time one we did, you needed a couple conversion factors for the most part because you don't know off the top of your head the relationship between days and minutes. Okay. So using this, I want to look at this earlier example. It says how many minutes are in 3.5 days? And let me show you how you would have, used a fence for that example. Okay. So you start with the measurement that you are given in the problem. That's the top left corner of your fence. In this problem, we're given 3.5 days. 3.5 is the number, days is the unit. That's important, okay? Because whatever unit you have top left has to go bottom right, okay? Now, we need to get rid of days and eventually get to minutes, but we don't normally associate days and minutes directly to each other. We usually relate days to hours, hours to minutes. So our next conversion factor is going to be days to hours. You know that 1 day equals 24 hours, okay? Well, if you look at the fence method, whatever unit you have up here has to go bottom right, okay? So we're going to put 1 day bottom right. And then you're going to put 24 hours top right, because that's the next unit that we want. And like in math class, your units, like anything that's on top and bottom cancels. So days cancel because one's on top, one's on bottom. Now we're at hours. We're not quite to the unit we want. The unit we want is minutes, okay? But do we know how to get from hours to minutes? We do, okay? We can get from hours to minutes because we know that 1 hour equals 60 minutes, okay? And again, hours cancels because one's on top, one's on the bottom. And then we have 60 minutes, which is the unit that we want. So we're officially done with the problem now, okay? I'm going to erase some of that line I have because I don't need the whole thing. So now we're done with our setup. We have the unit we want. We've gotten rid of the units we don't. What you're going to do now is you multiply across, so 3.5 times 24 times 60, and you would divide by the bottom, which in this case is 1 times 1, which you know is just 1, okay? And you would get 5,040, which most of you got. And the unit that you have not canceled out is your remaining unit. So in this case, it's minutes, okay? So that is how you use the fence method to efficiently do conversions. Because remember, a lot of you solve this problem by like doing days to hours, getting an answer, doing hours to minutes, getting an answer, then multiplying your two answers by each other. This way you just do one problem, you get one answer, you don't have a middleman. But you'll also see that I wrote down all my units and it's very clear what my conversion factors are. So I am like showing my work very efficiently. I have an answer with the unit, but I'm doing it all in one space, okay? All right, so let's talk about how this relates to units in chemistry. Remember, you learned about the mole, right? This question says, how many grams are in 0.250 moles of MgBr2? All right, I'm going to switch to Ren for a little bit more dramatic. Okay, again, whatever goes top left is what you're given in the problem. If you look at the problem, you're given 0.250 moles of MgBr2. I would encourage you to get in the habit of writing the substance down, because next week when we use a fence, you're going to be doing two substances in one fence, and you're going to get confused about which number goes with which substance if you don't actually label, okay? So in this case, I'm starting the fence with what I was given in the problem, which is 0.250 moles of MgBr2, okay? I've been asked to find grams, all right? What is the relationship between moles and grams? Well, if you go back to your notes, the relationship between moles and grams is the molar mass, right? 1 mole of MgBr2 weighs whatever we would find if we added up the masses, which you did already. There was a purpose behind what I had you do, right? When we did this problem, remember, we found the molar masses. I had you do MgBr2. And this is how you found the molar mass of MgBr2. Okay, you added up the masses from the periodic table. So if you go back to your notes, you already know that for every 1 mole of MgBr2, it weighs, I think it was 184.113 grams of MgBr2. Okay, let me just double check that that number was right. Yep, okay. Moles cancels out. We're left with grams, which is what we wanted. And then using your calculator, okay, I'm gonna side by side this. Oh, of course, it's gonna give me an app. Hold on. There we go. Okay. I have to wait for the X to pop up. There we go. Okay. Ugh. No. Let's try again. Okay. Now I have my calculator. All right. We're doing 0.250 times 184.113. Okay. Divide by 1. I would get in the habit of making sure you're dividing by the bottom. It's going to be 1 a lot of times on these first few, but it's not always going to be 1. Okay. And then you guys, here's your answer, your calculator answer, right? Okay. I want you to look at that. You don't write that whole thing down. This is why we learned about sig digs first. Okay. you have to look at what we started with. Your answer cannot be more specific than your initial measurement, okay? Now, conversion factors, remember, rule number 5, you don't have to worry about conversion factors, okay? That's all significant, that's not determining it. This, you do, because it's a measurement. So how many sig digs is in 0.250? 3. Significant, significant, significant. This is just a placeholder, okay? So that means I get 3 sig digs in my answer. Go over to your calculator. I get that spot, I get this spot, and then I get this spot, but I have to look past it to see, should I round or leave it? In this case, a 2 comes after the 0. So we're gonna keep the 46.0, okay? So our answer is gonna be 46.0 grams of MgBr2, okay? And that is how you solve problems like that, right? That's how you use the fence to convert from one unit to another. All right, well, here's another one. Why don't you go ahead, pause the video and see if you can set this one up. I'll give you a little hint though. I tried to make your life easy. You already have the molar mass of NaNO3 on that other worksheet that we did, okay? It's 84.994. So that's saving you a little bit of work on these first examples, okay? Pause the video if you need to. Set it up on your own and then hit play when you're ready to see me do it, to see if you did it correctly, okay? I'm gonna set it up right now though, so this is your last chance to pause, okay? All right. Ooh, that one line's really crooked, isn't it? We'll erase that, redo it. Oh. Do that again. All right, here we go. 39.7 grams of NaNO3. That's what you're given in the problem. Okay. Now, again, we're going to use a conversion factor here. Okay. We need to get to moles. The relationship between grams and moles is molar mass. Please remember, whatever unit is top left has to go bottom right. So in this case, grams of NaNO3 is going on the bottom and mole is going on top, okay? What do we do with grams? How many grams? Well, that's this number, 84.994. That's the molar mass that we found the other day. So 84.994 grams of NaNO3 for every 1 mole, okay? Grams cancels, right? And we're left with moles, which is what we want. So we have the unit we want. We only needed 1 conversion factor. And now we're going to get our calculator going again, hopefully without Candy Crush this time. And in this example, we're multiplying across 39.7 times 1 equals, and then we're going to divide by 84.994 equals, okay? And what we're going to get there is all that calculator vomit. Ask yourself, how many sig digs do we get? Okay. And then write down what you think the answer should be. Pause it if you need a minute. Okay. And hopefully you wrote down what I'm about to write down. Although I forgot, so give me a second. All right. 0.467 moles of NaNO3. Okay. There you go. All right. Okay. Good. All right. And then moving on. Now let's talk, I have my examples labeled wrong. All right, now let's talk about atoms, okay? This says how many atoms are in 1.27 moles of helium, all right? You're gonna set up your fence the same way. You're starting with 1.27 moles of helium, okay? Make your fence. Now here's what I'll tell you. We need to get rid of moles and we need to go to atoms. My question to you is, what conversion factor do we use? Do we use molar mass? No. Okay. Molar mass gets you from moles to grams. We don't want to go moles to grams. We want to go moles to atoms. What do we know about moles to atoms? This number, 6.02 times 10 to the 23. Okay. So I'm going to scroll down. I know that 1 mole is equal to 6.02 times 10 to the 23 atoms. Moles cancels. I have atoms. Okay. Now all I need to do is put it in the calculator. You need to pay attention. Okay. I'm going to pull this calculator up. All right. Now, because I'm doing a split screen, I'm going to have to scroll. Like, I just want to show you. I don't have all my functions available here. So I can slide to the right and it gives me more functions. The one I'm looking for is EE. Okay. EE is what you use to do exponents on the calculator. Some calculators have it as EXP. All right. So you need to look at your calculator that you're using and figure out which one of these two buttons do you have. These buttons are designed to help you do scientific notation. So use them. Don't type times 10 caret. You end up making mistakes that way if your exponent's on the bottom. So I'm going to suggest you do it correctly. If you're using a graphing calculator, okay, let me tell you where you find your EE button. Find the number 7. Look above it. There's the comma, right? In the second function color, you'll see an EE above that comment, the comma button. So to use EE, you're going to hit second comma, and that's going to put an E on your screen if you're using the graphing calculator. If you're not sure how to do this while I'm gone, my suggestion to you is to actually don't worry about your device today if you're not sure how to do it. I mean, try, but if you don't know how, wait for me to come back and see you on Monday, and then I'll help you learn how to use your device for this, okay? You can use the one on the iPad because I'll show you how to do that, right? So what you're gonna do here is you're gonna type in 1.27, right? Times, because remember, you multiply numbers together, like that are next to each other. Follow me, and this is important. Okay, I'm going to do 6.02. 6.02. Pay attention. I am not hitting times. I'm not hitting this. Instead, I'm hitting EE. This button tells the calculator you want to do scientific notation. I hit EE, you'll see my EE down here. And then I'm going to type 23. So this is 6.02 EE 23. That EE takes care of the times 10. Okay. So you don't type times 10. You hit the EE or the EXP button, and that takes care of the times 10 for you. And then I'm going to hit equals, and I'm going to divide by 1. Okay. This is what your calculator gives you, which looks kind of weird. First of all, you get 3 sig digs. 1, 2, 3, except I should round up because that's a 5. So I'm going to do 7.65. Okay. That E means times 10. So you're going to write times 10. Do not write E. That's calculator speak. You're a human. You're not talking like a calculator. And then what's your exponent? 23. Okay, so that's how many atoms are in 1.27 moles, sorry, of helium. Okay. All right. Last one. Are you ready? Here we go. This one's a little harder. Okay. How many molecules are in 10.0 grams of NaCl? All right. So what are we being given here? We are being given 10.0 grams of NaCl. Similar to the time problem, what do you know to connect grams to? Molar mass, right? Through molar mass, you know how to connect grams to moles. You can use the periodic table to find out how much 1 mole of sodium chloride weighs. Okay. Let me grab the periodic table real quick. Okay. So on your periodic table, sodium is 22.990 and chlorine is 35.453. Okay, so 22.990 plus 35.453. And you get 58.443. Okay. So that's the molar mass of sodium. All right, so that means grams cancels. Now we're at moles. Do we have the unit we want? No, we want molecules. Do we know a relationship between moles and molecules? Yes, we do. The relationship between moles and molecules is also this number, 6.02 times 10 to the 23. Okay, so, scrolling. Here we go. I'm going to extend my fence. So, ooh, that was a really bad line, wasn't it? So it'll actually look like a fence. Okay. And I know, like if moles is top left, it has to go bottom right. I know that 1 mole is equal to 6.02 times 10 to the 23 molecules. Okay. Moles cancels. I have molecules, which is what I want. So now it's time to get out my calculator. All right. So 10.0 times 1 times 6.02. Gotta scroll back over. EE 23. So I just multiplied across. I'm going to hit equals. I'm going to divide 58.443. I'm going to hit equals again. And I'm going to divide again by 1. I divide by everything individually on the bottom, just so you know. Like that way my order of operations doesn't get messed up. Okay. And then I'm going to look, how many sig digs do I have in 10.0? This one's tricky because there's a lot of zeros. Is that significant? Is that significant? This one is because it's after the 0 or after the non-zero to the right of the decimal, which means this is significant because it's between. So it's 3 sig digs. So I get 3 in my answer. 1, 2, 3. I don't have to round because that's a 0. E23 means times 10 to the 23rd. 1.03 times 10 to the 23rd molecules. And that's your final answer. Okay. So that's how you problem solve. I would encourage you to next, all right, you have 2 things to do for me today. The first thing you're going to do, this one I already did for you, right? We did that one. That's the one. Yeah, we did that one right here. Okay. So here's what I'm going to encourage you to do next. Okay. Try this one now. How many molecules are in 15.0 grams of CaOH2? It's like the last example that we just did with the sodium chloride. I just want to remind you, you already found the molar mass of calcium hydroxide up here. So what I'm gonna say to you is, try this one on your own, check in with a neighbor, compare what you guys did, look at that last example with NaCl over here, okay, this one, and see if you set it up correctly, okay? And then there's an assignment on Schoology for you to do, all right? So just try your best. I'm sorry I'm not here. Just show work. If you finish, you can submit. If you don't want to, if you're not quite finished or you're really confused, you can wait till Monday. We'll go over it, okay? So that's fine. Just watch the video, try your best, okay? And we'll see how it goes on Monday. All right, thank you.